Hello everybody. So in this particular video, we'll be going through the second part of third module, which is trusses. So we have already completed the first part, which is support reaction in beams. And this is the second part, which is trusses. So let us try to understand what a truss is. A truss is a structural member. Truss is a structural member, or it is a frame. Truss is a structural member or a frame which is constructed by joining a number of straight members, So let us try to understand this in depth. A truss is a frame or a structural component which is constructed by joining a number of straight members in this way. So if you have a number of straight members, you join it properly in this way. You join it properly to form a frame, to construct a frame. So you have three straight members here. Straight member number 1, straight member number 2, straight member number 3. You have three straight members. And all of these straight members are connected, are joined together to form a truss. This particular structure or frame is called as a truss. So trusses will serve the same purpose as that of a beam. Trusses will serve the same purpose as that of beams. A beam is a horizontal structural component. A beam is a horizontal structural component in this way. It's a single component. Whereas a truss is a composite component. It's built using a number of straight members. Beam is a single component. Beam carries vertical loads. Whereas the trusses also carry vertical loads. So truss will serve the same purpose as that of a beam. So even a particular truss will be supported. If in the case of beam will be supported by hinge support or roller support, is it not? Or simple support or fixed support. Even the case of trusses, you have supports at the end. Even trusses will be supported. Either by hinge support or roller support or simple support or fixed support. So a particular truss will serve the same purpose as that of a beam. Even a truss will carry vertical load. A number of vertical loads. So this is the meaning of truss. Truss is a frame or a structural component which carries vertical loads, which will serve the same purpose as that of a beam, and it is constructed using a number of straight members, constructed by joining a number of straight members. And all the straight members what you join, or the joints at which two or more straight members come and join, will be connected using smooth frictionless pins or hinges. Or straight members will be connected using smooth pins or frictionless hinges. So in this particular example, these are the loads: load 1, load 2, load 3. We'll ignore the loads for time being. So you have three straight members. Straight members will be three straight members. And how many joints do we have? Joint number 1, joint number 2, and joint number 3. So number of joints is also 3. So you have three straight members and 3 joints. Let us just go through. I'll just show you some of the examples or some of the images so that you can understand what a truss is. I'll share the image so that you can understand. Hope you can see the shared screen. So this is one of the examples. For a truss. So as you can see, so these are the straight members. Which are joined together to form a truss, or it is a structural component. So in this particular example, if you observe, the truss what you have carries vertical loads from the roof. So let me show you one more example. Let me share the screen. Hope you can see the shared screen. So this is also one of the examples. You can see a number of straight members. This is one of the straight members. All of these are straight members which are joined in a particular way so that it serves the same purpose as that of a beam which carries vertical loads from the roof. Vertical loads from the roof. Let me show you one more example by sharing the screen. Just give me a moment. Hope you can see this. So you have a number of straight members. This is a typical example for a truss. You have a number of straight members, 1, 2, 3, 4, 5 straight members joined together to form a truss. Form a truss. Hope this is clear. Now, there are two types. Two major types which comes under trusses. The first type is perfect truss, and the second type is imperfect truss. These are the two major types. Now, how to check the perfectness of a truss? How to check whether the given truss is a perfect truss or an imperfect truss is the question now. So, in order to classify the trusses, this comes under classification of trusses. So, in order to classify the trusses, you have an equation which will help you to determine whether the given truss is a perfect truss or an imperfect truss. You have an equation, and that equation is this: n is equal to 2j minus 3. So this particular equation will help you to determine whether the given truss is a perfect truss or is an imperfect truss. So where n is number of straight members, and j is number of joints. J is the number of joints. So let us check the perfectness of this particular example. By applying this formula, by applying this equation, which is n is equal to 2j minus 3, where n is the number of straight members and j is the number of joints. So n is equal to 2j minus 3. 2j minus 3 is the equation. So number of straight members is 3 here. 3 is equal to 2 into number of joints is also 3 minus 3. So 3 is equal to 3. So n is equal to 2j minus 3 in this case. So this is a perfect truss. This is the perfect truss. If n is not equal to 2j minus 3, if n is not equal to 2j minus 3, then it will be imperfect. So when n is not equal to 2j minus 3, two more cases arise. N can be less than 2j minus 3 or n can be more than 2j minus 3. So there are two more cases which comes under this, where n is more than 2j minus 3 or n becomes less than 2j minus 3. So when n is less than 2j minus 3, it is called as deficient trusses, and when n is more than 2j minus 3, it's called as reductant trusses. So n is equal to 2j minus 3 is that particular equation which helps you to determine whether the given truss is a perfect truss or an imperfect truss. So let us just go through the classification of trusses once again. Hope we can see the shared screen. See, this is the definition of truss. A truss is a pin joined frame made of several straight members connected by smooth pins or hinges, which are called as joints. Again, to check the perfectness of a truss, so this is the equation: n is equal to 2j minus 3, where n is the number of members, j is the number of joints. So this is all about the classification of trusses. See, trusses are majorly classified into two types. The first type is perfect trusses, where n is equal to 2j minus 3, and the second type is imperfect trusses, where n is not equal to 2j minus 3. So when n is not equal to 2j minus 3, n can be less than 2j minus 3 or n can be greater than 2j minus 3. So when n is less than 2j minus 3, such trusses are called as deficient trusses, and when n becomes more than 2j minus 3, then such trusses are called as reductant trusses. So this is all about the classification of trusses, or different types of trusses available. Now, as we went through earlier, a truss will serve the same purpose as that of a beam. A truss will serve the same purpose as that of a beam. So let us compare a truss and a beam, and let us try to understand the difference between both. There's a major difference between a truss and a beam. Even though both serve the same purpose, there is a difference between a truss and a beam. So let us try to understand the difference between a truss and a beam. So let me consider a truss with 3 straight members and 3 joints. And let me consider the hinged support and the roller support supporting this particular truss. And let me consider a beam as well. Beam is a single entity, single structure with, say, hinge support and a roller support. Roller support. Let us try to understand the difference between beam and trusses. The difference between beam and trusses. So both beam and truss carries vertical loads. Carries vertical loads in this way. Carries vertical loads. Here, in the case of beams, since there is only one structure, the load will be straight away carried by the supports. Load will be straight away carried, or it will be distributed equally to the support straight away. And when load is distributed to the support will offer reaction, and that reaction is called a support reaction, as you went through in the previous case. But here in the case of trusses, when a particular truss carries some vertical loads, it will not be transferred to supports straight away. So it will be passed through all the straight members. And finally it comes to support. Or all the straight members what you have, which forms a particular truss, will carry some load. But here there are no straight members. There's only one member here in beams, whereas in trusses you have a number of straight members joined together. So all the straight members will carry certain amount of load or force because of the vertical load. So vertical load will not be straight away transferred to the supports. It will be passing through all the straight members. Or in other words, all the straight members will carry certain amount of load here. And finally it will be transferred to the support. So finally it will be transferred to the supports, and when loads are transferred to support will offer support reaction. So in the case of beams, in the previous part, it was enough if you calculate only support reactions, RA or RB, RA, RAX, or it was enough if you had calculated only support reactions. But here, in the case of trusses, it's not sufficient if we calculate only support reactions. Support reactions are necessary, but along with support reactions, you have to find all the forces which runs through all the straight members. This is the main difference between a truss and a beam. So in the case of beam, it's enough if you find only the support reactions, but here in the case of trusses, it's not sufficient if you find only the support reactions. You have to find the forces which runs through all the straight members. So this is one of the major differences between a beam and a truss. And trusses are made of straight members which are steel structures. So basically a truss is a steel structure, and beam will be usually made of concrete. So these are the difference. These are some of the differences between truss and a beam. So as you know, trusses carry vertical loads, and vertical loads will be transferred to all the straight members, and finally it will be transferred to the supports. I'll just share the screen and show you an example for this. Hope you can see the shared screen. So here you can see a number of vertical loads. Acting, is it not? But all the vertical loads are passed through these straight members, and finally it will be transferred to the supports. If you observe the diagram properly, all the vertical loads will be transferred through these straight members, and finally it will be transferred to the supports. Hope you can see the shared screen properly. Now, since all the straight members carry certain amount of load or force, there are two types of loads which a particular straight member carry. There are two types of loads. The first type is compressive load, and the second type is tensile, or compression and tension. A straight member will be either under compression or will be under tension. So as you know that every straight member carries certain amount of load here, load or force. The load or force carried by each straight member can be either compressive or it can be either tensile, or a straight member can be under compression or under tension. It depends on the external load. It depends on the external vertical load acting on the truss. So if a straight member, let us consider one straight member in the case of compression and in the case of tension. One straight member, this is the straight member, this is the straight member here, and this is joint, this is joint, this is joint. Let us try to understand the nature of load. So if a particular straight member carries compression or compressive force, or if a particular straight member is under compression, the load will be acting towards the joint, or force will be acting towards the joint. Force or load will be acting, let me write it as force, will be acting towards the joint. If a particular straight member, I'm speaking about one straight member here, if one single straight member carries compressive load, or if it is under compression, loads or forces will be directed towards the joints. So if the same straight member is under tension, or if it carries tensile load, or if it carries tensile force, force will be always directed away from the joints. Force will always be directed away from the joints. Force will always be directed away from the joints. You have to remember this very well. This is how you indicate. Just by going through this, you'll understand whether a particular straight member carries compressive load or tensile load. So if the force is directed towards a joint in a particular straight member, in a single straight member, in one single straight member, if the forces are directed towards the joint, then it carries compressive load. Similarly, if in a particular straight member, if a force is directed away from the joint, as that of this particular case, it carries tensile load. These are the two types of loads or forces which runs through all straight members, here in the case of trusses, which runs through all the straight members. It can be either compressive or tensile. So let me just take you through the last theory part available, which are some of the assumptions made in trusses. So let me share the screen and show you some of the assumptions. Hope you can see the shared screen. So these are the nature of forces in the truss system, as we discussed just now. If it is a compressive load system, or if a particular straight member is under compression, force will move towards the joint, and if it is under tension, force will move away from the joint. This you have to remember. We have considered one straight member with the two joints. So these are the four assumptions made in trusses. The first assumption is frame will always be considered perfect. Here, as far as the problems of trusses are concerned, frame will always be considered perfect. All members are joined through hinges or pins, which are frictionless basically. So frame will be loaded only at the joints. Frame will not be loaded at the center of a particular straight member. As far as the problems which are given to you, it will not be loaded. It will be loaded only at the joints. Self weight of members are neglected. It's constructed with the help of a number of straight members, and the self weight of all the straight members are neglected. Will not be considering the self weight of any of the straight members. So this is all about the theory part which is related to trusses. You need this theory part in order to solve the numericals. Especially you should know this, the nature of loading system. You should be in a position to identify whether a particular straight member carries compression or whether a particular straight member carries tension. If it carries compression, then the forces will be directed towards the joint. If it carries tension, then the forces will be directed away from the joint. This you have to remember. Hope the theory part related to trusses is clear. So let us continue with the problems in the next video. Thank you.